Okay, section 3.3, day 2. This is a continuation of CPCTC. We're going to do 3 proofs today. The first one, we're going to use CPCTC to get angle 1 congruent to angle 2. So it looks like we have AE congruent to FC, FB congruent to DE, and we also know angle 3 is congruent to angle 4. Okay, so right away I have enough information to prove these baby triangles congruent on the sides, but I really want to prove angle 1 is congruent to angle 2. So the triangles that they want me to get congruent are this one and then this one up here. Okay, again, here's angle 1 in the corner, and here's angle 2 in this corner. This is an F, here's my angle 6. So right now I have AE is congruent to FC. Well, that's not an entire side of the triangle I want to prove. It's part of it. The other side I could add to it would be EF. So I'm going to say AE is congruent to FC. That's a given. And from the diagram, we can go ahead and pull that EF is congruent to itself. If I use addition and add those together, I can get the whole segment, which is AF and EC. Okay, that's my first side, but I still need a little bit more information. Let's look at our angles right now. I have angle 3 and angle 4. Well, 4 is right next to 5. Those two are adjacent. Okay, so since 4 and 5 are adjacent, and angle AEF is a straight angle, I can say 4 and 5 are sup. Okay, 4 and 5 are going to be supplementary. Same with 3 and 6. So go ahead and write angle 3 and 6 are adjacent. Angle EFC is straight, and 3 and 6 will be supplementary. I am given that 3 and 4 are congruent, so I'm going to write that underneath. Okay, because I have 3 and 3 and 4 and 4, I'm left with angle 5 is congruent to angle 6, and that's my A. So right now I have side angle. Can I find another side? Well, I forgot my other given. I do have FB is congruent to DE. This is my last side, and now because of side angle side, I can get the two triangles congruent to each other. Okay, this is triangle AFB, and then that would be congruent to triangle CED. Okay, knowing that, I can now say that angle 1 is congruent to angle 2. My reasons, step 1, 2 is the same for both. We have 3 here, 4, and a fifth one right here. Let's go ahead and write those down. Okay, step 1, what's happening here? Oops, I forgot a step. Let me go back. So it should be 1, 2, 3, 3, 4, 5, and 6. Sorry about that. Hopefully you're using pencil. Step 1, how did I get EF congruent to itself? Well, because I know it's reflexive. So number 1 is reflexive. 2, how did I go from AE and add EF to it? That's addition. I'm going to add. Step 3, how do I get a supplementary angle? If adjacent and straight, then they are sup. Step 4, we have sups of congruent angles are congruent. Sups of congruent angles are congruent. 5, I get side angle side. And step 6 is CPCTC. Corresponding parts of congruent triangles are congruent. All right, number 2 is probably the hardest one on the page. 2 is actually called a detour proof, which we will get in the next chapter a little bit more. but we're just kind of introducing it here. What they're given is AB is congruent to EF, AC is congruent to DE, and DB is congruent to CF. Those two segments are congruent. So we are going to go ahead and start to prove the triangle's congruent. Right now it looks like I'll probably have enough information to prove that ABD is congruent. So this one here is congruent to CFE. Okay, and then I'm going to take a detour and try to get these little triangles congruent inside. So this one here and this one here. Then I can prove angle 1 is congruent to angle 3. So go ahead and write down, let's go with our first one. AB is congruent to EF. Okay, this is a side, so I can count that as my first side. Now I have AC congruent to DE. Now that's part of the side, so I'm going to use this reflexive piece here, CD, and use addition to add. So that will be the whole side, AD, and the whole side, CE. Now I have those two pieces in there. Okay, again, so AC and DE are not part of my triangle, but I can take the reflexive piece out. CD is congruent to itself. If I add those two together, I'm left with the side of my triangle, which is AD is congruent to CE. Okay, and that's my second side. Third side, I think they give me DB and CF. Go ahead and write those down. So this is my third side. Now I can go ahead and prove that the two triangles are congruent to each other. Triangle ABD is congruent to triangle. So if I'm going ABD, I have to start with EFC. Okay, now knowing that, can I pull out anything that will help me prove that these triangles, the little ones inside, will be congruent? Because now that is what I'm trying to do. I'm trying to prove this triangle congruent to this triangle. Okay, I already have one side of it from the given, but can I pull anything else that will help me? Okay, so what I could pull out is an angle D and angle C. Angle D is congruent to angle C. And that would be my angle. I believe I already have a side. BD is congruent to CF. And I know the reflexive piece, CD, is congruent to itself. Okay, this is already reflexive that I know. This is given. So now it looks like I have a side, angle, side. Go ahead and group those three and say that the two triangles that are highlighted are now congruent. Triangle BCD is congruent to triangle. So if I'm going BC to D, I have to go FD to C. Looks like I have angle 1 and angle 2 in those two. So now from CPCTC, I can say angle 1 is congruent to angle 2, and I'm done. Okay, let's go back and number our problem. So we have step 1 here, 2, 3, 4. This is the same step as step 1, so if you want to save steps, you can put a 1 there. 5 and 6. Okay, if you understand that, go ahead and put a 5, and then this will be 6 and 7. But since these are the same rays, instead of doubling it, I'm just going to write it once instead of twice. So my first reason, something equals itself, that's reflexive. Step 2, when I have AC and I'm adding it to CD, I'm using addition again like I did before. 3, side, side, side. Okay, 4, how do I go from triangles to parts of the triangles? Corresponding parts of congruent triangles are congruent, CPCTC. 5 is side angle side. And then 6 is the same. If you want to label this a 4 instead, you could also have done that. Or just write it again, CPCTC. Okay, since these are the same, you can just have this as being 4 instead of 6 if you want to do it that way. on to the last one, number 3. Okay, this one's much shorter than the last one. It's only 4 steps. Before we get into it, we have to know what the definition of a square is, okay, because a square is given. So we're going to use that reason def of square. A square gives us that all 4 sides are congruent and that there's 4 right angles in the picture. So we want to prove AY is congruent to YD. So it looks like we need these 2 triangles congruent before we do that. And then we can say from CPCTC that the parts will also be congruent. So I'm going to go ahead and put that ABCD is a square. Okay, knowing it's a square, I can say that all sides are congruent. And the only sides that will help me in this case are AB side and DC. So those are the only 2 I'm going to write down. Because it really doesn't help that AD is congruent to BC in this case, because the triangle is ABY and triangle DCY. Okay, so I just proved that all 4 sides are congruent because the definition of a square proves that. Also, from a square, I can say that all 4 angles are right angles. So angle B is a right angle, and angle C is a right angle. And it's not going to really help me that I say that angle XDC is a right angle or BAD is a right angle, because this is not going to be an angle inside the triangle. Okay, so far I have a side. I have angles, but remember I have to have them congruent before I move on. So I'm going to group these and say that angle B is congruent to angle C. Now I have an angle because it's congruent, and I'm looking for another side. It does tell me that X and Y are midpoints of AD, so I use the fact that it was a square. This is done. Why don't I say now that X and Y are midpoints of AD and BC? So if X is a midpoint of AD, I have AX is congruent to XD. And if Y is a midpoint of BC, I can have these 2 also going to be congruent. Different symbol here. So let's go ahead and write that down. Okay, so knowing that X and Y are midpoints, the only thing that's going to really help me in this is that BY is congruent to YC. Okay, since those 2 segments are going to help me in my triangles that I want to prove, this will be my last side. So now I have side, angle, side. I can go ahead and group the 3 and say that now triangle ABY is congruent to triangle. Let's see, if I have ABY, I must say DCY. And now I can say AY is congruent to segment YD. And I'm done. Go ahead and write down the numbers. So I know it's a square. I know it's a square, and I know it's a square. A square tells me a couple things. So my first one's going to be definition of a square. 2. So 2. How do I know here? It's going to be definition of a midpoint, because it says midpoint in the actual problem. Number 3. How do I know that right angles are congruent? Because I know all right angles congruent. Number 4. This one's easy. Side, angle, side. And number 5, which is corresponding parts of congruent triangles are congruent. And I'm done with that proof. Done for today. Hooray.